Any questions about this problem? Okay, let's do some simple problems. But this is a really good problem to understand the importance of second translation theorem. Okay. Next example is this problem. I will give you a function ft defined sine t 0 between 0 and 2 pi and 0 if t is greater than 2 pi. This is the function and find the Laplace transform of this function. Right? Can you give a try? First try to sketch the function and then try to write down the function as a combination of the sketch functions.
Really quickly, is it cosine that goes through the zero axis, or I mean the origin, or is it the sine?
Sine. Sine 0 is 0 and sine 2 pi is 0. So how do you sketch this function? You have to sketch sine t in between 0 and 2 pi. So your graph would look like this, right? 0 and pi. Okay. This is the graph of sine t in between 0 and 2 pi. And when t is greater than 2 pi, you have 0. Right? So this is the graph of ft. Right. Now what is our target? Our target is to find the Laplace transform of this function. Let's try to represent this function as step function, as a combination of step functions. So how do you do that? So how do you get this portion? You have sine t would go like that, but you need only this portion. So what is the function that you have to multiply? Right? So how do you write it? ft equals sine t times, you multiply sine t by some function, you would get this portion. What would you get if you multiply sine t by ut? Then you would get this whole graph. Right? Then you would get the sine t in positive direction. Right? So what would you get if you multiply sine t by ut minus 1? What is ut minus 1? Ut minus 2 pi. What is this ut minus 2 pi? That means that is this function, right? Okay. From ut, you are going to subtract ut minus 2 pi. Ut is this one, and ut minus 2 pi is this portion. So if you subtract ut minus 2 pi from ut, you would get this portion, right? So what would happen if you multiply this and this? If you multiply sine t and function, you would get only this portion. Okay, so sine t would go like this, but this function is 0 when t is greater than 2 pi. Okay, so this is the representation. So this is equal to, I would commute these two terms, minus 2 pi and sine t. Right? Any questions about this point? Right? If I explain that further, this is what is going to happen, right? So you have sine t. So what is the graph of sine t? Sine t would look like, right? It would go like this, 0 and 2 pi. This is sine t. What is ut minus 2 pi? Is this? This is the graph of ut minus 2 pi. Okay? If you multiply this and this is 1 would be multiplied by this portion, and 0 would be multiplied by the rest. Okay? So this portion would disappear, this portion would disappear, you would get only this. Okay? Right. So that means you would get exactly 50. Is that clear? Right. Now we know what is FT, right? So that's why at the beginning of the course, at the beginning of the Laplace transform, when I was introducing ut, I mentioned that it is going to be very important. Right? So that means we can capture the region that we need by using the step function. Okay. Right. Now let's apply Laplace transform to both sides. Okay. So this sine of t times ut minus sine of t times t minus 2 pi. Then I would apply Laplace transform for both sides. Then I would get Laplace transform of ft. Then I would apply the linearity. So from the linearity, I would get Laplace transform of sine of t times ut minus Laplace transform of sine of t times t minus 2 pi. Okay? Right. Now we are in a good position, right? So this is something that we know, right? What is the Laplace of sine? Ut. Yeah.
As per S over S plus.
That's cosine.
So this one, the
Laplace
other
of-
side, it would be K.
Laplace of sine omega t would be omega divided by s square plus omega square. So instead of omega, I have 1. So what would I get? 1 divided by s square plus 1. Okay? This is what I get for this one. Right? But this is the problematic part. Right? Now I know that Laplace of sine t times ut is this one. In other words, I know the Laplace transform of sine t. To apply second translation theorem, I need to have sine t minus 2 pi, right? Because what does it say? Second translation theorem states that Laplace of ft minus a ut minus a is equal to e to the minus as fs. Okay, that's what second translation theorem says. Okay, so but from trigonometry, what can you say about sine t and sine t minus 2 pi? What can you say about sine t and sine t minus 2 pi? They are going to be equal, right? Suppose you have an angle like this, and what is t minus 2 pi means? Plus 2 pi means you are going to rotate in counterclockwise direction, and minus 2 pi means you have some angle and you are going to rotate in clockwise direction, 2 pi. Then you would end up at the same position, right? That means suppose you are here, suppose this is your angle t, and you are going to rotate clockwise direction by 2 pi radius. So you would end up at this point. So nothing would happen to your angle. So instead of sine t, I am going to put sine t minus 2 pi because both of them are same. So what is this? Sine t minus 2 pi to t minus 2 pi. Okay? I used trigonometry. Right. Now I can apply second translation theorem. Okay? Now instead of ft, I have sine t. Right? And I know the Laplace transform of sine t. Okay? And what has happened in the time domain? There is a translation by 2 pi. Okay? So what would happen in the Laplace domain? You have to multiply by e to the minus 2 pi s, because instead of a, I have 2 pi minus 2 pi s times Laplace of sine t. Okay? I know the Laplace of sine t, that is 1 divided by s square plus 1. So I would get 1 divided by s square plus 1 minus e to the minus 2 pi s divided by s square plus 1. Okay? Is that clear? Thing that you recognizes this is the translation of this is the translation of sine t times ut. Right? Any questions? Another way to remember the second translation theorem is this. I'll show you that way also. That means, suppose you know the Laplace of t times ut. Is fs. Okay. Then Laplace of ft minus a ut minus a is going to be equal to e to the minus a is Laplace of du. That's what I used here, right? I know the Laplace of 50 ut, that is sine ut. Then I can write down the Laplace of this function by the second translation theorem. Okay. Another way to remember second translation theorem. Any questions? Let's go to another example. My next example is t is equal to t zero, t is greater than or equal to. Right. Okay. Can you give a try? This is also kind of similar to previous problem, but the function is different, right? Instead of sin t, we have it's known that gt equals t in between 0 and a, right? So you would get a linear graph. Yeah. First, we will sketch this function. It is t in between 0 and 8. Like that. Right? So at t equals, say, what is the y value? It is also going to be equal to 8. Okay? So this is your graph, right? In between 0 and 8, my graph is t, and when t is greater than or equal to 8, the value is 0. Okay? Right. Then, as usual, the next task is to express this function as a combination of step functions. Okay? So, what can I say about this function gt? It is going to be equal to gt times ut. Gt times ut means the whole line, right? Because ut equals 1 and gt equals t. So then you would get whole line, and if you subtract times t minus 1, you will get this portion. Or you can think about this, right? So suppose you have the graph, this graph. Suppose you have y equals t, right? Suppose you have y equals t, right? You need to capture this graph in between 0 to 8, right? This is the graph of y equals t. You would like to capture only this portion. Only this portion. Right? That's the idea, right? Because this is my graph. Right. So how do you capture this portion? This is the graph of t. Okay. So how do you capture this red colored portion? First you are going to multiply t by ut. If you multiply t by ut, you will get the whole graph. Okay. And you are going to subtract t times ut minus a. What is t times ut minus a? That is the graph after point A. Right? So if you subtract this portion from this, you would get the red colored portion. Okay, that's how you capture this portion. Okay, this is equal to dt. Right. So so I would write dt. dt is equal to t times ut, minus t times ut minus a. Okay. Right. Now I represented the given function as a combination of the step functions. Right. Next, I can apply Laplace transform to both sides. Okay. Let's take the Laplace transform. On the right hand side, gt is equal to Laplace of t times ut minus Laplace of t times ut minus a. Right? Okay. First part is easy, right? Again, you can apply this formula. Laplace of t to the power n is factorial n divided by s to the power n. So what is Laplace transform of t? When n equals 1, I have 1 divided by s to the power 2. Okay, that part is easy. Right. Now, what can we say about this second piece? What can we say about this piece? Can we apply second translation theorem directly into that function?
Little part.
You need t minus a, right? If you have t minus a, then you're fine. But the problem is we don't have t minus a, right? So next, I'm going to make this t into t minus a by using some algebraic trick, right? So this is what I'm going to do. Instead of t, I would write t minus a plus a. So still I'm having t, right? Instead of t, I replace t by t minus a plus a times ut minus a. Okay? Right. Then I would distribute this. I would take a bracket, put a bracket to this t minus a. Then I can decompose this. Now 1 divided by s to the power 2 minus Laplace of. Now I am going to write this in this form. T minus a times ut minus a. T minus a times ut minus a plus a times ut minus a. Okay? Right. Okay. Any questions so far? Any questions? Right. Next, I would apply linearity again because I have addition of two functions, right? And a is a scalar, so again I am going to apply linearity. So by using linearity, I can have 1 divided by s to the power 2 minus Laplace of t minus a to t minus a minus, I take a out, Laplace of ut minus a. Okay. Now I'm almost done. Okay. Because what is the Laplace transform of this function? Let's use the formula that I used, right? Now I have translated t by a units in the time domain. So that would result in multiplication by exponential in Laplace domain. Okay, so I will get 1 divided by s square minus e to the minus s times Laplace of tut. Okay, that's what I introduced before, right? They applied second translation theorem. Again, u has been translated by a unit, so what is the Laplace transform of this? Again, e to the minus s times Laplace of 1 times ut. Okay. Right. Now we are almost done. What is the Laplace transform of t? Again, by that formula, Laplace transform of t is going to be 1 divided by s square. Okay. Get a times e to the minus as. What is the Laplace transform of ut? It is 1 divided by s. Okay. So I'm done. Right? Any questions about the second translation theorem? Let's do more examples. Right. If you have any questions, you can ask. Go to another example. Now in the previous example, I gave sine t and I defined ft as sine t when t is in between 0 and 2 pi. Now I'm going to give the same problem in a different way. Next example is if t is going to be equal to sine of t when t is in between 0 and pi divided by 2, 0, when t is greater than pi divided by 2, right? The problem is to find the Laplace transform of function ft. Okay. First try to sketch function. I will sketch that then try to represent that. Dx is ft and sine t from 0 to pi divided by 2. 0 is okay. Right. First, try to represent this function as a combination of step functions. Then apply linearity and second translation theorem. These are the key ideas that we are going to discuss. The Laplace transform. So these two are the only remaining portions. Convolution and Dirac delta. So how do you represent this function as a combination of step functions?
Sin t ut minus pi over 2
Times sin t.
times
So yeah, because we have sin t is going to be equal to sin t times ut minus sin t times u t minus pi divided by t. Because if you multiply sin t by ut, you would get the whole graph, and it's up, if you consider sin t times ut minus pi over 2, you would get this portion. So if you do the subtraction, you would only get this piece. Right? Okay. Now this is the representation of ft as a combination of the step functions. Okay. Right. So let's take the Laplace transform in both sides. Right? And I will apply the linearity also. So then I can try Laplace transform of my function ft is going to be equal to Laplace transform of ft sin t ut minus Laplace transform of sin of t ut minus pi divided by 2. Right? We know the Laplace transform of sin t ut. It is going to be equal to 1 divided by s square plus 1. Okay? Right. Now again, to apply the second translation theorem, I need to have sin t minus pi divided by 2. Right? Because second translation theorem would say that Laplace of ft minus a times ut minus a is equal to e to the minus as times fs. Right? So again, as I did in the previous problem, again I need to make this t to t minus pi divided by 2. Right? But in this case, in the previous example, we had a linear function. But in this case, we have sin t. Right? So let's try to do that. Right? So again, I'm going to replace, and in this case, sin t is not going to equal to sin t minus pi divided by 2. Right? So I cannot use the trick that I used in one of our previous examples, because if I have 2 pi there, then I can write sin t minus 2 pi instead of sin t. But in this case, I cannot do that. Right? Okay. So this is what I'm going to do. Instead of sin t, I'm going to write t minus pi divided by 2 plus pi divided by 2. Okay? So I did not do any harm to my original expression. Right? Still I am having sin t minus pi divided by 2 plus pi divided by 2 times u t minus pi divided by 2. Okay? Right. Okay. Then I would put another bracket to this t minus pi divided by 2. Okay? Now consider this as one. Consider this piece as a single term. Right? This is A and this is B. Okay? Right. Let's suppose this is theta. Let's suppose this is theta. Right? Then let's consider that portion. So what is sin t minus pi over 2 plus pi over 2? Consider this is theta. Okay, so I have sin pi over 2 plus theta. So what is the value of sin pi over 2 plus theta? That is negative cosine theta from trigonometry, right? Okay. Theta is t minus pi divided by 2. So negative cosine t minus pi divided by 2. Is that clear? In the exam, if you need those string identities, I would give them as a hint, right? Sin pi over 2 plus theta. Give me a second. This should be positive because we are second quadrant. It's positive cosine t minus pi divided by 2. Right? Okay. Now I know what is this expression. Right? It is going to be equal to cosine t minus pi divided by 2. Right. So I'm going to replace this expression by cosine t minus pi divided by 2. Q t minus pi divided by 2. Okay? Right. Now I have a nice function, right? And I can relate second translation theorem. Okay? Right. How do I relate second translation theorem to this? We can relate that because we know the Laplace transform of cosine t. Okay? What is the Laplace transform of cosine t? Is the Laplace transform of cosine t ut? That is equal to s divided by s square plus 1 square, that is equal to 1. Okay? This is the Laplace of cosine t. Now let's apply translation in time domain. Let's translate this function by pi divided by 2. Right? Laplace of cosine t minus pi divided by 2 q t minus pi divided by 2. Okay? What can you say about this one? By the second translation theorem, this is equal to e to the minus pi divided by 2s times Laplace of cosine t qt. Okay? E to the minus pi divided by 2s. What is the Laplace of cosine t ut? That is s divided by s square plus 1. Okay? I applied second translation theorem. So now I have the answer, right? So my final answer is Laplace transform of t equal to 1 divided by s square plus 1 minus e to the minus pi divided by 2s s divided by s square plus 1. And I have done. Right. Any questions so far? Have 2 more minutes. 1 minute. Another problem came into my mind, so I would like to give that to, but that would be a good extrapolate problem. So I'll give that on next Tuesday, right? Okay, we'll stop from here. If you have any questions, you can ask.